please say hello to Dr. Phil Nuytten. A fascinating combination of underwater technology and enterprise. Have a look at the program book. You'll see the companies this guy has created.
Thank you. Well, I want to talk to you about a project just like Jean-Michel did that we're involved in right now. And it's interesting how many people seem to be, all of a sudden, interested in cities under the sea and living under the sea. And with the very short time available, it's difficult to take you to that place in a meaningful way. So on the idea that we need to see the tools that are available to us and where I want to go, and on the idea that 1,000 pixels is worth 5,000 words, or whatever the local saying is, I'm going to roll a bit of videotape so you can see some of the things I'll be talking about right afterwards, and put an idea or an image to the word. So, Maestro, if you'd care to roll the tape. We seem to have no audio. There is audio on this if you want to bring it up. And apparently not. Well, what we have here, I'll ad-lib then. This is Bruce Robeson and Dr. Joe McGinnis looking in the deep ocean off Monterey Canyon at a depth of 1,500 to 2,000 feet. And this is what you see down there. And if you could hear Joe, what he'd be narrating is talking about the machines and devices that we use to explore the deep ocean. And these devices in the deep ocean, and by deep I mean in depths exceeding 1,000 feet, are all 1 atmosphere devices. And that is that they are at the same pressure that we're at now. Moses, any chance of getting the audio up, do you think? What I'm saying there, I believe, there will be a short technical pause while they see if they can get the audio up. What I was actually speaking to was the...
They're working on it, Phil, so...
I'm sorry?
They're working on it.
Okay. The idea is to go down... Well, let's go back to fundamentals. We all have the idea that human beings are... And we speak this way, that human beings are like cockroaches. They will survive no matter what, that we're tough, resilient, that we can go anywhere, do anything, and that is an unadulterated crock of you-know-what. We are not at all tough, resilient, strong, invulnerable. We are like a jellyfish full of chopsticks. We're very weak, very fragile, and that goes back a long ways towards the design of human beings, and our design is very, very old. And I ask you to consider this. We live in such a narrow, if you were to take the highest mountain on this planet, Mount Everest, it's about 7 miles high. And if you were to move that out to the coast and move the deepest part of the ocean, the Mindanao Trench in the Philippines, move those together so that they were the largest features on the planet, the mountain would be 7 miles high, and coincidentally, the trench, the deep, would be about 7 miles deep. So that's 14 miles, the greatest spread, the greatest geographical spread on this planet. The grossest feature on this planet is only 14 miles apart. Well, this planet's 25,000 miles in circumference, 8,000 miles across. So if you think about 14 miles over 8,000, that means that the globes of the Earth that you've seen that we're all familiar with a mountain sticking up like warts, that is not true. This planet of ours, as you saw from the wonderful picture that Jean-Michel showed, and you will see Dave Williams' presentation, is as smooth as a glass marble. And the continents are swirly colors on that glass marble. They're tattoos. They're not, they don't stick up in the manner that we all believe that they do. So here we have it. We have this glass ball with 14 miles of gross difference, and in that 14 miles, we can't go there. We can't go to the top of Mount Everest naked the way we were born. We can't breathe. We can't survive in the temperature. We most certainly can't go to the bottom of the ocean in these enormous pressures. So we're constricted to this narrow band that we were designed to live in, and that is this primeval swamp that we climbed out of. We need the atmosphere, we need the exact pressure, we need the temperature, we need the right amount of oxygen. So we're very limited to a narrow band. And what does that tell us? We have audio? Yes. Oh, okay. Good. Well, I'll wind up this and we'll go back to the audio. So here we are. We have to somehow, live differently or live in this narrow range of design envelope, but we don't. We don't live there. We don't, when we fly from continent to continent, we don't run down the runways of our local airport flapping our arms and attempt to leap into the air, because we can't. We can't fly. We can't go to these places like the deep ocean except with the armor of technology. And that's my job. I'm really not an underwater adventurer in the same way that Jean-Michel is and so many of my colleagues are. I'm more of an armorer. I'm the guy that arms these warriors for deep water. And let's run this video and I'll show you the kinds of stuff that we're going to use. Okay, let's try again. Lights, cameras, action, video. It's a very quiet audio. It seems like you've seen this before. Ah, yes, there's Bruce Robeson, there's Dr. McGinnis. And if you could hear them, they would be saying. This is our little sub-deep worker. This is a 1 atmosphere, 2,000-foot work system that you can put into the back of a pickup truck. And anybody can build a big submarine, but it takes a lot of effort and a lot of miniaturization to build these little guys. And this suit on the right-hand side here, next to the mime, this is like an old Chaplin movie. This is wonderful. I'm just telling you exactly the same thing I told you a minute ago, saying, you have to get that wonderful brain, because although our bodies haven't evolved very much, our brain certainly has. We'll talk about that in a minute. This is the Nuyt suit. And the Nuyt suit is an armored diving suit, and it's really a submarine that you wear. So, and this is Jim Delgado up in Vancouver miming again to tell you that this is a wonderful deal. This is suit number 1, as you can see up on the outside there, or the right-hand side of the suit. This is one that we donated to the Maritime Museum years ago. And this is a fellow astronaut of Dave Williams. This is Julie Payette doing her zero-gravity training in the Nuyt suit. And you see the manipulators that are used. Now, the big thing about this is that these people inside these suits and inside these submarines are at exactly the same pressure as you are right now. 1 atmosphere, 14.7 pounds per square inch. And they do all these wonderful things feeling no effects whatsoever of the pressure. So with this suit, you can go down to 1,000 feet, 2,000 feet and stay all day, but it's big and bulky. And so the next generation is called the exosuit, and that's what you're seeing here. And this is a suit, again, an armored suit, but has full mobility, so you can swim with it. The primary means of locomotion is swimming. And again, this is wild with no sound. So this is an interview saying what the suit does, how we'll be swimming with it, what we hope to do with it, when it'll be ready. This is so recent that this suit isn't even completed yet. We'll be doing the final tests, I hope, this winter. We're so busy building these little submarines right now that we haven't had time to work on the suit. The time to get but we should. Here we go. Listen to this. After you spend 10 or 15 hours at 1,000 feet, the time to come back, 5 minutes. I think we're fortunate to be in the sort of generation that's the first ones to see this planet from space and to understand that this planet should not have been called Earth. It should have been called water, because it truly is a water planet. And I kind of, in my poetic moments, I like to think of myself as forging passports to allow us to visit the 3/4 of this planet that we were denied access to by birth. And so that's what building this equipment is all about, and that's what understanding the undersea world is all about. I really believe that we're the early explorers, the first wave that we're moving into this part of our planet.
Phil Nyutten envisions devices that will help him construct a self-sustaining station deep under the sea.
I am very interested and have been doing a lot of sketches and a lot of thinking about an undersea colony operating at 1 atmosphere in deep water. By deep, I mean 1,000, 1,500, 2,000 feet. And I have in my mind something very much like the sketches of the Mars colony, but taking place at a couple of thousand feet and centered around, clustered around the heat vents. Leave your colony to go to work, mining the heat vents for their minerals, wearing something like this, an advanced version, and driving something like the Deep Worker. So a very grandiose, ambitious scheme, yes. Doable? Absolutely, absolutely doable. And it's going to be done. If not me, someone's going to do it. Mark my words, it will be done. So I started doing sketches of what I thought the undersea Mars colony, and you'll be, coincidentally enough, Darlene Lim will be talking to a couple of speakers away from now about the simulated Mars colony. And here's where we want to go. The black smokers in the depths of thousands of feet. Now these black smokers start out, the liquid comes out of the vent clear. But what you see here is the dissolved metals contacting the cold water. This water you see here, the black water, is 350 degrees C, and it's hitting water that's 2 degrees C. So you have this incredible 600 or 700 degree F water coming out, and the metals that are dissolved in it are actually coming out of solution. Many people believe that the deep ocean is devoid of life, like a desert. You see here that's not the case. In fact, the deep ocean is exactly the opposite, and there's a growing school of thought that this is where life on this planet began, is around the heat vents. And so that's where we want to go. Now the lights again. And what we want to build down there is a 1 atmosphere colony that, I'm going to check my time here. Ah, yes, we're still glowing green, that's good. A 1 atmosphere colony that will use the heat vent as a source of power. It will be an artificial sun. It will provide the power to take the oxygen from the water, to provide life support, and to put the greenhouses down there to grow things. And what will we do there? What's the purpose of this? And the initial pilot study, the purpose will be undersea mining in a way that's never been done before. Any sort of mining is destructive. Undersea mining is not, because we'll actually be mining the fluid. And I give you a quick example. If you were to take your ring off and drop it into water and heat it up, one would expect that the ring would melt. But unfortunately, the water at about 212 degrees decides to leave the container and go off in space and leaves your ring sitting there. If you could heat that water up to the melting point of the melting temperature of the ring, then the metal would dissolve into the water, and as you cooled it, it would drop back out. Well, as many of you are aware, if you increase the outside pressure, you can increase the boiling point, and that's why water boils at such a high temperature on top of Mount Everest, and that's why the car radiators don't boil over, because they're under pressure. So what's happening, what you're seeing in the black smokers is 6 to 7% solid dissolved minerals dropping out according to their molecular weight. So if you take this fluid, take a ceramic snout, stick it into the heat vent, take this enormously hot fluid out, and according to the second law of hydrodynamics, or thermodynamics rather, if you take this fluid out and cause it to run a large Stirling cycle engine, you can create enormous amounts of energy to do all the things you want to do. And the exhaust fluid, once it's exposed to the cold water, has the minerals dropping out, and that's your product of your colony. Send that back to the surface, use it to build all the things that need to be built. So a very grandiose project, and you have to have these incredible tools in place to be able to do that. You have to go to 1,000 feet, 1,500 feet, 2,000 feet, down to the heat vents, build the colony there. But once having done that, remember you're at 1 atmosphere. So inside that colony at 1 atmosphere, you go out in something like the exosuit to work. You use for transportation something like the Deep Workers, and away you go to run your heat vents and do that sort of work. all sorts of interesting things come to mind that we don't know about. Whole species of creatures that are being found every day in the deep ocean that we had no prior knowledge of. Things like, well, we have to grow crops. Well, what happens to wheat, alfalfa, all these various plants that we wish to grow to provide another source of oxygen and a way of absorbing carbon dioxide? What happens when you try to grow them under pressure? Do they have to grow at 1 atmosphere? Work's been done in space, but none of this work has ever been done in deep water. If you take a grain of wheat and take it down to a pressure where it's 1,000 pounds per square inch all around you, will it grow? It's providing it has sufficient CO2 and sunlight. Will it grow? We don't know, but we're certainly going to find out. So the idea is to build a pilot project first that is a small, shallow water habitat, probably 100 feet deep, something like that. Dave Williams, the next presenter, will be showing you the Aquarius habitat off Florida. And that's the sort of thing that would be a wonderful pilot project for this. We're going to do the same thing as the Aquarius habitat, except at 1 atmosphere. So instead of being like other habitats where they're at the same pressure as the surrounding water, heat vent-based alpha will be 1 atmosphere. Everything will be done exactly as it would be done in thousands of feet of water, because it makes very little difference once you're sealed in this thing and working out of the suits and working in the subs. If you want to go deeper, you just make it thicker. It doesn't really matter because you're always at 1 atmosphere, so you're always at the same pressure that we're at now. So that's the kind of scheme, and it's actually kind of interesting the way this has all come together, because it pulls together all these various disciplines in fields, particularly fields like space, outer space. We do a lot of work with NASA. We provided a lot of, well, in fact, Dave, the next presenter up, is a pilot of the Nyutten suit, which you saw briefly there. Also has piloted the deep worker, Jean-Michel, of course. This is old hat to him. He's been at this for many, many years. And so it's kind of nice that I'm sandwiched in between people who get to use some of the armor that I've sort of created in my little blacksmith's forge to allow us to go into this deep water. And we're looking forward to doing this over the next couple of years. We're trying to sandwich, the necessity to build commercial vehicles. We build submarines, the deep worker, the whole batch of them, the dual deep worker, a side-by-side version of our little one. And so this is the kind of stuff we do for soup and underwear. And it's very much as Moses said earlier in speaking of Jean-Michel's family, and that is, it's a wonderful thing to be able to do exactly what you want to do and package this stuff up and flog it and use the proceeds to do even more of what you want to do. And that's exactly what we're doing at Nuytco. We're getting our soup and underwear money by building little submarines for commercial use, scientific use all over the world, building these hard suits, the Nyutten suit, which is being given or sold, not given, believe me, sold to navies all over the world and everything, and the proceeds used to develop ideas like vent-based alpha. So I kind of have in my mind that all of this will happen in the next 2 to 3 years, I believe. Certainly in the next couple of decades, you're going to see a lot more emphasis on the underwater world. And we tend to think of the ocean as kind of a big bowl, and it is kind of a bowl. And I see that this infernal machine is telling me that I'm going to have to wind up. I want to put you again in perspective, much like the glass ball or the glass marble. If you consider a soup bowl, not the kind that we normally have at the table, but the kind you have in fancy restaurants with a flat bottom and the little lipped edge, the continental shelf is like that 1-inch raised edge. The area we're familiar with is the little lip, and then the flat bottom is the abyssal plain. So that puts it in scale, except in order to be in scale, that soup bowl would have to be 3 miles across. So that's what it's like at the bottom of the ocean. That's where we're going. Just like we're going to the stars, we will go there one day. No question about it. Thank you very much.